Hi, so this is Engineer Usman again, and today with a new video talking about a renovation project in which we'll just give you a brief idea about a small horizontal and vertical extension of an existing house. For any type of estimating project, these are the very basic steps that we have to keep in mind before we start working. So the first step is the data review. It means what data we have. For example, the project that we discussed in this particular video, we have the written scope file and the drawings. We have to carefully read out the scope file before we move ahead towards the drawing, just to give a brief idea what terminologies that he has used, what technical language, and what kind of technical scope he wants us to cover. Then the drawings, we have to recheck if any page is missing. Sometimes we do have the table of content, we can re-verify if any detail or any page is missing. So we immediately have to put in RFIs, request for information, if any data related to our quantification is missing in the drawings. And it's a pretty normal thing. Most of the cases, maybe 40 to 50% drawings are lagging the details. So here, sometimes we have the capability to send RFIs, and sometimes we have to make engineering judgments based on our experience. So I'm going to let you know when the time comes about the decisions that we have to make if the details are missing. The very important step is the study of the drawings. If the estimate is going to take around maybe 4 to 8 hours, you have to spend at least 15 to 20 minutes reading the drawings to save you some time. If normally you are spending 8 hours, you can just save 2 hours by spending extra 20 minutes to study the drawings, just to familiarize yourself. You must visualize what's the drawing saying. Like in our case, we have different plans from talking from foundation, first floor, second floor, the attic, then the roof. These are the levels. Then the elevations, their front, right and left sides were being renovated, the rear side and some portion of the right and left side were not being renovated, both internally and externally. So the third step is the breakdown of the required items or scope. If we split the scope into our required, in a required, what we say, to fulfill the requirement, we can split out the scope. Like in our case, we first have to do the demolition work, then we got the foundation, the structural work, the shell of the building, then we have the erection. So very basic three divisions were demolition, the architectural, and the structural. I would say this demolition is pretty clear. The structure is the shell, the bones, you can say bones of a body. The architectural work is basically the flesh of a bone that we have to wrap on the bones. So the first step would be the demolition, the second would be the structure, then third would be the architecture. If you go in the sequence, you won't be able to commit any mistake with the estimation part. We can further subdivide this structure part, say foundations, then superstructure, this is substructure, and superstructure. Further, you can subdivide superstructure into first floor, the second floor, the attic, and so on. In architectural work, in most of the cases, maybe 90% of the cases, the division will be same. Just like the structure part, the doors, take it from the very easy part, doors, windows, finishes, roofing, exterior. These are the very basic items that I have highlighted. Same goes with the project that we already done it as a case study. Then after studying the drawings, after breaking down in your mind, if you are a beginner, I would recommend just write it with your pen and paper, so that you could familiarize, you could train your mind. Later on, after maybe 3 to 4 months, you would be enough trained that you could memorize this deviance, this breakdowns yourself in your mind, and just keep on doing the work. It will be just like driving a car that goes with your reflexes. So after that, there are markings. It's very easy if you have done this part, this and this part. If you have done it, this marking is just painting a drawing, just like the kids do. The you just have to paint the drawing if you have these in your mind. After the marking is done, we have to do the exporting of the results in the Excel worksheet. Just bear with me, and we're gonna be moving toward the screen recording where I'll show you what data I have, what documents I have, and how I interpret the drawings, and how I'm gonna be proceeding with the drawings for preparing the takeoffs, and then we'll move ahead toward pricing and preparing a complete estimate. So first of all, this is the drawing, a 7 pages drawing that I have already put in the markings, and in addition to that, we do have the specs or the detailed description provided by the architect. Sometimes when the architect and the client sit down and rectify their requirements or the needs, they note down the requirements of the client, and on the technical part, the architect makes some notes, and he compile it in a scope file that he can give you to further elaborate the requirements of the drawings. So page one is just you can say it's a key plan with an overview of the construction site. It's a 2.5 story frame dwelling. So this is the relevant information. Just this part is relevant to us. Then we got the drawing number, and we should focus on the latest revision. Here is the latest revision. We have to highlight this on our estimate when we have to report what was the latest data available to us based on which we prepared the quantity takeoff. Then carry on with the drawing pages A 2, 3. We just have to recheck the data. Then we'll go dive in to study the drawings. Here is the brief summary of the existing and new area. This is the foundation plan, as the drawing state, the first floor framing plan. Yes. So the scale is already written on the plans. After that, the first floor plan, the second floor framing, the second floor, and then on that the attic framing. The scale of the attic framing, as you can see, is I guess halved. So we're gonna be calibrating this particular part. Sometimes we do have discrepancies in the lines, so we have to take the decisions based on our own experience and judgment. So this is the attic plan. After that, we're gonna be having the roof plan, and just the pattern I told you. After the plans, we'll be having the elevations. This is the pretty standard detail. Then we're gonna be having the section and a few of the details. And on the last page, these details are the cutting from a standard company, joist company, and these are pretty standard details. On every lumber project, these are the standard details like the hangers, the anchoring. This will be pretty standard. So going from start, we have around 9 feet of extension. Here, there you can see the existing walls, existing crawl space walls that we have to remove. The space beneath that will be excavated, and we have to prepare 8-inch concrete block wall. On top, on above this area, we have the steps, the slab on grade, and above that we have this girder framing. On the first floor, we have this hatch pattern walls, are the newly added walls. We should be conscious about the joint between existing and new wall. So because sometimes most of the estimators miss this part where we have to do the patchwork on the areas where existing and new walls are joined. So most of the estimators do this mistake of skipping this part. So on the rear, there gonna be nothing pretty. Everything is existing. We don't have to do anything else. This wall is the load bearing wall. Is stated in the specs that it will be by others. You can just search it. Okay, already completed. The statement says it's already completed. So we're gonna be skipping this part. Then the floor, after floor, we're gonna be having. If we look up, we'll be having the second floor framing plan. Here the details: 2 inch, 2 by 12 inch at 12 inch over center. So here you can see the typical framing is spaced at 12 inches. But in most of the cases, you can say more than 90% of the cases, you're going to be having the spacing to be not more than 16 inches or maybe around 16. This 12 inch is exception over here, maybe because of the loading of the above structure. Either there are walls or there are floor joists. The spacing they mostly keep it to be 16 inches because the research have proven that it's an economical spacing to achieve. So this load bearing wall is existing. We don't have to. Uh, yes, we have to sister existing second floor joist with 2 by 12 each side. So the sistering means we have to join new joist to the existing on both sides. So sistering will reinforce the existing joist structure to support more loading, or maybe the existing joists are in rough condition. It's done on similar basis, just like we do the new part, but we just have to redraw it on both sides because it's written on each side. So then we've got the second floor framing, second floor plan. Here are the new walls on the perimeter, the windows, the ceiling lights. Sometimes, sometimes the architect might converge both the RCP plans and the floor plans in the same drawing just to save some time. But in most of the cases, you'll find reflected ceiling plans, that is RCP plans, as a separate drawings apart from the floor plans. Then we have the attic framing. This is the projection of the attic framing and the existing. And in a similar way, we got the attic and the roof framing. In roof, it has used ML Valley, that is micro lamp. It's engineered wooden beams that are being used. In some cases where the loads are more, I mean, if we use the standard beams, it might be uneconomical or it won't be able to capture all the load. So the engineered beams are being used to economize and at the same time to take more loads. These are the notes that we must have to read out or study at our own. So in this elevation, this is front elevation. Things are pretty clear. On the right side, this is the left side and the rear. One advice that I would like to do over here is always at least once you read the drawings, correlate your floor plan to the elevation to get the exact idea of the elevation. Sometimes there are returns that are hidden in the elevations that we cannot see in the elevation but are clearly visible in the plans. So coming from first floor, and this is the initial elevation. If we correlate, these are the steps. Here you can see the steps, and then the inner door. This is inner door, the windows. Okay, so coming to the upper level, second floor, framing we won't be able to see in the elevation drawings. This is the second floor plan, and you can see these two projecting windows. You can see from here, these are the joining windows, and on the attic we won't be able to see the framing, of course. Then the attic plan, here you can see the detail of the projection. There are two windows. This double door, sliding door, is behind the this area. So I would again repeat that you should correlate the floor plan to the elevation at least once you start the drawing. So I've already done the markings, and here you can see the linear measurement, the area measurement, and the walls. Everything is color coded based on the drawings and the available specs. Before we start marking, since I've already done it, you should add the viewport and make a window like this. Okay, then you have to put the scale. It's good if the scale is already written. If not, you can easily calibrate it based on the ready available dimension. In estimating, we can set the precision to 1 inch because it's estimate and not an exact measurement. So after that, you have to recheck the dimension like I have already done it. Here is the measurement tool. Previously, in our previous video, we used Bluebeam 17, but now we have upgraded it to Bluebeam Rev 20. It's a little bit different in terms of views, in terms of sorting of the tools, but everything is available in it, just like the Bluebeam 17. So we have put a dimension, it's 5'7", a reference dimension, one horizontal and one vertical. The plus point that I observed in 17 and Rev 20 is they have put in a separate Y scale. Previously, the separate Y scale, the vertical axis scale was not available. You just have to put in two scales, either X or Y, then you have to calculate. Because Y, sometimes we do need to change the Y scale, the vertical scale, in when the profile is longer, like in the case of roads or longitudinal sections of a road or drain or culvert or any kind of utility lines. But in most of the cases in buildings, we don't need to change the Y scale. Okay, so again, like the reference dimension, 20 feet, 6 inch, it's okay. This is the very critical part, the scaling of the drawings. If the scale is wrong, everything is wrong. And we always encourage you to add the scale in the viewport. Do not add the scale in this page. I mean, globally, you can scale the drawing, but not every scale on the drawing, all on the complete drawings are can be same. Like in this case, static framing plan, the scale is written 1/4, but I'm pretty sure this is not 1/4 scale. So we can get a reference dimension. It was 20 feet 6 inches. We can just calibrate it, like we can add like this. Okay, select a region. Now we have to be careful. We have to make a window just for this particular scale. This is custom. Okay, we have to calibrate. We're gonna be putting in the dimensions like this, feet inches, and the precision is had to be 1 inches. Calibrate. It's gonna ask the provide me with the reference dimension. From the previous plan, we already know this dimension is 20 feet 6 inches. 20 feet, 6 inches. Either you put in inch sign or not, it's gonna recalculate it. But for fit, we have to put in the fit sign. So it's calibrated. Uh, since we already have the dimensions put in, it's already up there. So it's not updating. If the scale would be different, the dimensions will automatically be updated. So here you can see we already had these scales installed. You can just delete it here from this page or document from this page. Yes. So we'll just redo the stuff for you. Add window, then custom, inch, fit inch, precision, calibrate, non-dimension. It's 20 feet, 6 inches. Apply. So this is just the scale for this particular area. You can see the blue window. Dimension is already updated. We'll just reapply that dimension and recheck. So all good. See, we don't have the scale for this area. We just deleted it. We can re-add it and it will recalculate. If the scale is wrong, no need to redo the marking. You can just keep the marking there and then rescale it. The calculations will automatically adjust. The scale was already written, so we have put in. So everything is updated. We can recheck like this. Okay. So in this way, we can scale the drawing, review the drawings of a project. We can first get an idea what items are to be done, what are not to be done. I'll just give you a brief summary on the board, what I interpret from the drawings, and what things you should keep in mind while preparing this kind of extension or renovation estimate. This is a little bit of renovation, horizontal and vertical uh, extension of an existing building, existing residential house or building. So, so the markings will take a lot more time. It will be difficult for us to record the video, detailed video. We can just provide you the brief idea about the dimensions. We use the length dimension from here, the perimeter, uh, the area dimension from here. As you can see, either you can make a poly. This is the area dimension, like we already told you. And you might see that there are different colors in the area and the length dimensions. You can redo the formatting, like select this and you can change the colors based on your own needs, own requirements. Uh, so, so the question is why we use different color codes, different colors, different formatting. The right answer would be for an estimator, it's easy to get the exact idea based on the colors. Like in our case, uh, this purple color wall is thicker than this green one. So we have to decide. Same is the case for the blue one. So these color coding will easily distinguish between the type of the walls. We can easily have an idea. Like if I uh, just I put in the wall in the search bar to separate the walls from other area. You can see there are three colors. So there are three type of walls. Same is the case for the windows. If the size is same, the color is same. If the size is different, the color is different. It help us a lot in interpreting the drawings just by looking at the color coded drawing. So we can create a legend of what working we have done. we can readjust it based on our requirements, and we can reformat this legend. It will summarize whatever is in that particular page that we have quantified so far. So it helps in presentation when the other guy is looking without, if you don't have the blue beam, he can easily uh, review the drawings based on the PDF drawing that you're going to share. So here are different items that you can highlight, maybe the top bar. You can fill in the white color so that it should not be transparent. So these are a couple of things that you can have it with you for changing changing the format of the legend. So you can see over here we have different walls like these strut walls, the purple, the green, and the blue. These are different types of walls, and the quantity is also written here, the linear fit. In the legend, the item that is the measurement of a particular thing will be written in the legend. Like in case of count, it's count. In area, it's area. But if we come here in area, we also have the length. But the legend, in the legend, it will be written the area. Same is the case for the volume. When we're gonna use, we're gonna elaborate. So in this way, we can do the marking, the interpretation of the drawings and the markings, and it will be a laborious task to do the markings. You have to be patient. It takes some time. We can provide you with these marking times to help you understand, to help you interpret and at your own place. So that's all for today. We're gonna be with you in the next video with some new project uh, with same pattern of elaboration. Maybe it can be a commercial building. So stay tuned with us. Subscribe to our channel. Thank you and have a good day.